Hello, everyone. My name is Terry Noon, and I am the chair of the Ontario Forage Council. And I'd like to welcome everyone here today for our third and final session of the Forage Focus 2021. This is our third of 3 webinars for this year's virtual conference. If you have any questions, please type them in the Q&A feature, and Christine O'Reilly will share them with the presenter at the end of the talk. Thank you to the Dairy Farmers of Ontario, Noon Forage, Steelhead Ag, A&L Canada, Ontario Sheep Farmers, Kemin, AgriSolve Inc. for their generous partnership of this year's webinar series. Everyone who registered will receive a link to the recording should you wish to watch the session again later. The webinar will be posted on Ontario Forage Council's YouTube channel. So feel free to subscribe to be notified when the conference videos are posted. If you're on social media, please use #ForageFocus. Today's webinar is brought to you by Minto Ag Limited and AgriKing Inc. Our presenter is Dr. Kim Cassida. Dr. Cassida is the Extension Forage and Cover Crop Specialist from Michigan State University with degrees from Penn State and the University of Maine. Her extension program focuses on all things forage, and her research program focuses on management of alfalfa, perennial, and annual mixtures in ecosystems. In her spare time, she raises sheep. At this time, I'd like to welcome Dr. Kim Cassida.
Well, I'm going to be giving you a, I guess a smorgasbord of information here today about various things that we've been doing with our program over here in Michigan. I think a lot of what we do here is going to be quite relevant to you over in your environment in Ontario. Probably we should do more collaborations across the border, although sometimes that's hard to do just because of rules and regulations. But hopefully you can take something home from me here today. I'm going to start out talking about some work we've done with reduced lignin alfalfa. We've been working with this quite a bit for a few years here. We've done a number of different trials, and I'll try and give you an overview of what this is all about and what we have discovered. So the idea behind the reduced lignin alfalfa, of course, is a way to help alleviate the trade-off we always have between yield and quality when we are growing forages of any type, but particularly alfalfa. So we're all aware of the yield curve. After we've harvested or at the beginning of the season, you get a gradual increase in yield until it peaks and then starts to drop off. So we all like to see plenty of yield because that's the primary thing usually driving profitability per acre. But we also want to see good forage quality, and we know that as alfalfa becomes more mature, the forage quality represented here as RFQ, relative forage quality, is going to decline. The idea behind the reduced lignin alfalfa is that because it contains less lignin, it's still going to decline over time. But because it's starting at a lower point, you're going to have a delay in that reduction in quality. And that could potentially allow you to delay your harvest from when your optimal date might be about at this point where the quality and normal RFQ lines are intersecting. If you could get an extra week of growth here, you would still be at the same point of RFQ, but you would have some additional yield. And so the optimal date when you might harvest the reduced lignin alfalfa could potentially be later. And the idea here is that this would enable you to get equal annual yield and quality in fewer harvests with better persistence, because the idea there is that because you can get more per yield, you may be able to reduce the number of harvests you have per year. And this is an illustration of what happens there. This is just a matter of time. So here we have a typical growing season across the bottom, with alfalfa being harvested at 28, 33, or 38 days. So what you can see happen here, the blue line is every 28 days. And if you start towards the end of May, you will be able to fit in 5 harvests over the year before you get into that no harvest zone in the winter. Or you could delay this last harvest later and take it after a frost. But either way, you can get 5 harvests in. If you go to a 33-day interval, the green line, you're going to be starting a little bit later to take advantage of that extra growth in the spring. And each one of your harvests is going to be pushed later. So in approximately the same time frame, you can see you're only going to be able to fit in 4 harvests. And with 38 days, it becomes even more spread out. So this is supposedly a benefit for our alfalfa because you are putting less traffic over the field. And also it's a benefit for your profitability because getting the same amount of yield in fewer harvests is going to be helpful when you look at the cost of production. Now, one of the first studies we did with this was Michigan was involved in what's often referred to as the 6-state study, which was sponsored by Monsanto and Forage Genetics. And this was the first study that was done looking at the potential of the early reduced lignin varieties or a variety with a typical high yield alfalfa or a high quality alfalfa. This was done exactly the same study in 6 different states across the United States. See the stars representing where we were located here. It was planted in 2015 and we did 1 complete production year in 2016. And the idea was to see whether this Harvextra trait would hold up over a lot of different environments. So what we found, if you look at our chart here for yield, and on the chart, the blue line is a conventionally bred high yield alfalfa, one selected to be in the upper tier of yield potential. The red one is a well-established high quality alfalfa, the WL355RR, and the black line is our experimental Harvextra. So what we found was that there was a little less yield with the Harvextra at each one of our cutting dates, 28, 33, or 38. But you have to ignore that for a second because remember what we are trying to look at here is that we are able to delay the cutting of the Harvextra compared to when the high yield or the high quality conventional would be done. So if we look at 38 days for Harvextra and then draw the equivalent yield line back to what the 54R02 and the WL variety were able to yield at 28 days, you can see that our Harvextra is actually yielding more. So we're still good because we've been able to delay the harvest and get more yield. If you look at the same type of relationship for our NDF, which is down here in the lower right corner, again, the proper comparison here is to look at the amount of NDF that is in the reduced lignin variety at 38 days versus the conventional varieties back over here at 28 days. And so you can see that it does have more NDF in it at that point. But if you look at the NDF digestibility, which is really where the rubber meets the road, I hope you learned about this yesterday when you were learning about your feed results. The digestibility of that NDF at 38 days for Harvextra is equivalent to the digestibility that you had for the conventional varieties 10 days earlier, but with more yield. All right. So this preliminary information did suggest that Harvextra pretty much does what we expected it to do. We've done some additional work here. I have a study that was done only at MSU where we took a little bit different approach. We were still looking at the difference in harvest schedules. We spread that, we spread it out a little bit more over 2 weeks because we particularly wanted to compare Southern Michigan versus Northern Michigan. I'm just going to be presenting you the Southern Michigan data today because the two trials ended up being out of sync due to some planting problems, and so we haven't actually finished the one in the UP yet. But we took 6 commercial varieties in this case. These were varieties that were actually available commercially, not experimentals, and we planted them and then grew them out for 3 years while harvesting every 28, 35, or 42 days. So what we found in terms of dry matter yield is shown in this chart. This is averaged over the 3 years. Well, actually, it's totaled over the 3 years, sorry. And what we have here is the 3 conventionally bred high quality alfalfas are shown over here on the left-hand side of the chart, while the 3 Harv Extra HVX varieties are on the right. And to our, actually, we really liked this result. We did find that the WL high quality variety was significantly better than any of the Harv Extra varieties in yield. But if you look at our other conventionally bred, the AFX and the High-Just variety, they were, the Harv Extra have caught up with them. So our yield drag that we saw initially is basically going away. That's what we expect to see as new traits come on the market. So our yields are roughly equivalent. When we look at our quality, again, we do find that our Harv Extra, again, over here on the right, tend to be lower in lignin. But a little bit to our surprise here, we found that there wasn't always a statistical difference in lignin between our Harv Extra and some of our conventionally bred high quality varieties. And this also showed up in our NDF digestibility. If you look here, our conventionally bred WL variety was never as good as Harv Extra, nor was our AFX variety, but our High-Just variety actually was statistically similar to one of our Harv Extra varieties over this period of time. So this is not to take away from the Harv Extra trait, but I think what the question that this raises is, what do we actually know about quality in some of our conventionally bred alfalfa varieties? And to look at that, in 2018, we had done forage quality analysis on the first cutting of 2 of our alfalfa variety tests that we were doing here in East Lansing. Now, these are just commercial alfalfa variety tests. And as it so happened, in those particular years, we did not have any Harv Extra varieties entered in our test, but we did have several HQ varieties, which are shown here on the charts as the blue circles. And what we tried to do here was look at dividing the yield and RFQ of these varieties into quadrants based on high versus low. So the quadrant you would most like to be in would be this high dry matter yield and high RFQ, right? Nobody wants to be where both of those are low. Nobody really wants to be where it's high dry matter yield and low RFQ. But we might be able to take a little bit of a hit in dry matter yield if we could get a premium for better forage quality here. And you can see where the HQ varieties tended to fall either in the low dry matter yield, high quality, or the high dry matter yield, low quality. That surprised us a little bit, or right on the line. This is a second trial over here. Again, we didn't have any of our HQ varieties actually show up in both high dry matter yield and high quality. And some of them were taking that hit on the dry matter yield, just like we have been seeing in our Harv Extras. But I think the key here to look at is that we had a number of varieties here with just the solid black dots that were just conventional varieties that we weren't expecting anything special out of in terms of our quality, but they fell into this quadrant. Now, the problem I see is that most of our public alfalfa variety tests do not report quality. And the question I've been asking is, should they? Of course, we're losing public alfalfa variety tests across the United States as well as in Ontario. I believe you lost your test a few years ago because the companies are just, in part, not interested in entering. And if we were to add quality to the tests, it's going to increase the cost even further. But with the way alfalfa is currently being marketed in terms of quality being a key feature, it seems to me that not having a quality comparison makes it very difficult to make good decisions about which alfalfa to grow. Another question about the reduced lignin alfalfa is whether or not it will affect persistence of the stands. And this chart shows our study done here in East Lansing with those 6 commercial varieties, averaged across varieties just within the harvest schedules. And what we found here is consistently over years, the 35 or 42-day harvest interval is going to out yield the 28-day interval. But a little bit to our surprise, until I stopped to think about it, if you look at year 1 and year 2 are pretty much the same, little bit of a boost between year 1 and 2. And then we see a drop in the 3rd year, which is typical of what we expect with alfalfa. But what we are not seeing here is a big difference between the harvest intervals. The difference among them stays pretty much the same across years. We're not seeing a big drop with that 28-day interval. And then when you stop and think about this, though, the issue here is with small plot studies, we try very hard not to drive on our plots. And so they do not have any stress applied to them from traffic. And this is quite likely going to make them persist much better than a commercial alfalfa field would, where you would have all that extra traffic from the extra cuttings. Similar to this, we looked at a study that we had in here with a 28, 35, or 38-day interval cut for 3 years. And in the 5th year, we went out and dug crowns on that study in the spring. And again, to our surprise, we did not find much difference in crown health. We had the same number of crowns per square foot, and all of them were well over the threshold of 5 that we want for a productive stand. And there was really no difference in size of those crowns. But again, there was no traffic in this study. So none of the Harv Extra varieties have been out long enough on the market to have significant production data on how long they would last. They really only were on the market to a large extent where you could buy them in 2018. And so we're going into our 3rd, 4th year now where people can start to get some production data in from actual commercial fields on this with traffic. So some of our pluses and minuses for these longer harvest intervals are you might see fewer weeds because you have more competition from your alfalfa. Hopefully we're going to see that improved persistence where the traffic factor is being applied. But there's also a downside. If you're leaving that material out in the field for a longer period of time before you harvest it, you do have the potential that weather could happen. Whereas if you had harvested it a week early, maybe you might have avoided it. That's just something you have to weigh out for yourself. One thing that we have found here in Michigan, which has not been a problem in the other locations doing this work, is that we do occasionally hit the 50% bloom stewardship threshold here. If we have a summer cutting where we're having a little bit of drought stress, particularly in the 2nd or 3rd cutting, we have occasionally hit 50% bloom before we reached our designated cutting date. And of course, when you buy GMO alfalfa, you are agreeing when you buy that seed that you will not let it go past that point. So there may be some instances where you can't take advantage of the full interval of time and have to go in and cut it just because it hit 50% bloom occasionally. Another question that has come up is when you leave the alfalfa standing in the field longer, are we just going to see increased leaf loss from disease, particularly fungal diseases? And here's just a photograph showing the bottom of the canopy in a stand of alfalfa that's been out there maybe a little bit longer than it should. And we're actually seeing a significant number of dead leaves in the bottom. So we piggybacked on top of one of these trials, a fungicide treatment, because we were just curious at looking at this situation. And this is a picture from first cutting here in Michigan. And you can pretty clearly see the control alfalfa on the right. There's a lot of dead leaves in the bottom of that canopy, whereas the one that was treated with a fungicide has green leaves. This particular part of the study was done in Michigan, Ohio, and Wisconsin only amongst the 6 states, because they don't have, in the drier climates, they don't have as much problem with leaf loss. But we applied pretty much the high label rate of Priaxor to our stands in the first, second, and third cutting in 2018 and 2019. And here are our results. We had significant improvement in alfalfa yield in the first, second, and third cutting across those states. And to our somewhat surprise, we also had a significant improvement in yield in the fourth cutting. And we did not put any fungicide out in the fourth cutting. So this is purely carryover from improved health of the overall alfalfa from those previous 3 applications. By the time we got out to fifth cutting, we no longer had a boost from our fungicide. But overall, the boost that we saw here was 0.32 tons per acre per year, which was about a 6% improvement in overall yield. And that's going to have to be balanced against the cost of putting out the fungicide. And one of the things that this has brought home to me is that we probably need to be doing a few more trials looking at things like fungicide rate. You know, could you cut back the rate? Do you have to put out the high rate? Could you get by with a low rate? Do you need to do it first, second, and third? Or could you get by with just first and second? How would we play with these numbers to get the best cost effectiveness while also improving the yield? And I'll also point out here that these are averaged across all of the varieties. We did not find any difference among varieties for susceptibility to fungicide. So this is purely a matter of how long you're leaving the alfalfa in the field before you cut it. It has nothing to do with the Harvextra trait specifically itself. I'm going to move on a little bit into some grass trials. This is some work that we're doing here looking at the compatibility of alfalfa with different species of grass. This is a study where we grew alfalfa in a 50% mixture with either orchard grass, tall fescue, or meadow fescue. So we had it as a pure stand. Here, the dark green is our alfalfa by itself. And over here on the right, we have our 3 grasses by themselves. In this particular case, we found not too much difference between the tall fescue and the orchard grass as a monoculture yield. And the meadow fescue did pretty well. When we mixed them together, we had significantly better yield from any of our mixtures. And again, the meadow fescue was the star of this particular trial. So here in the States, anyway, we're seeing a lot of interest from farmers in growing alfalfa in mixtures with grass due to some advantages with fiber digestibility. And also because many of our hay markets want a mixture rather than a pure stand. And this illustrates the benefits you can see from that yield-wise. Another thing that we're doing some work with as people become more interested in growing grass with their alfalfa, people are interested in knowing which grass they should grow. We try and match that up, of course, so that the maturity of our grass matches up with the expected cutting dates of our alfalfa. But one of the things the grass industry grass seed companies have told us is that they don't have a good way to evaluate that. Each company basically uses their own system for evaluating grasses as to whether they mature late or early. So we have a research effort that's actually being driven by the grass seed companies because they want to see some collaboration amongst companies so that they can compare, for example, DLF Pickseed could compare their varieties to the ones put out by Behrenberg or Grasslands Oregon so that they have a standardized index across all species that they can relay to the buyers. And so everyone is talking about the same thing. So those three companies came up with this idea where also MSU is involved and the University of Kentucky and the American Forage and Grassland Council. So what we've done is established a number of different grass nurseries across the country where we have taken these 6 perennial or common perennial forage species, and we are looking at the maturity dates of different genotypes. And you notice I don't have any actual variety names in here. This is because those of us who are doing these measurements on site, we don't even know what varieties they are. We do know obviously what species they are, but they want to take any bias out of this so that we can't have a favorite variety that we can say, oh, well, we think this one should be early, so we're going to call it early. And so we're just measuring heading date as day of the year for each of these varieties. Here is just showing the data, how things will rank. Obviously, we see differences amongst species, and we're also seeing a considerable amount of variability within species from the earliest date to the heading date, or latest date here for Timothy. Now, if I take this same data and rearrange it from high or from low to high across all varieties, this is what we get. So what we are hoping to get finally from this data is we would be able to pick varieties that mature consistently about every 5 to 7 days across the growing season. We would then reveal which varieties those are, what is the name of that variety, and then they would become reference varieties that would be used to assign a specific heading date to new varieties that come on the market or old ones that are out there, and be able to define them as being early or late as actually how early or late are they. And then this could then be used by people when they're trying to select a grass to fit in with a particular system. And we are statistically seeing some hope that this is actually going to work. We're actually pretty excited about it. It's a few years out before we would have this for people to use, but it does look promising that we actually be able to pull this off. All right, I'm going to spend the remainder of my time talking about alfalfa autotoxicity because this is a project that we're spending a lot of time on here in Michigan. This is a problem that affects anyone who grows alfalfa anywhere. Of course, what it is that we have an unknown water-soluble compound or compounds, plural, that make alfalfa toxic to its own seedlings. And that will be maintained in the field for an uncertain length of time that depends on things that are both out of our control, such as soil type and rainfall. Basically, you get what you get on those, unless you're irrigating. And then we have things that are management dependence that we can control a little bit, such as our stand age and density at the time we terminate the alfalfa, the variety, the time we wait after termination before we replant, or tillage. Now, I'll note that because I was looking around on your Forage website a little bit yesterday, you do have a page on autotoxicity there, which mentions a particular compound called metacarpin as being the culprit. But the most recent research actually shows that metacarpin is probably one of the things that are in the mix, but there are probably multiple toxic factors, and we do not know what all of them are at this point. So the consequences of this problem are that you can get reduced or failed establishment, as shown in this picture right here. The plots on the left are quite spotty, has blank areas as opposed to the one on the right, which is better. But even more important, we get something called auto conditioning or auto suppression. Completely failed establishment is pretty easy to see. You don't have any plants. You can recognize that you have a problem and decide what to do with it. In auto conditioning, you actually have plants. You are damaging the root of the plant. However, the toxic factors will affect often the taproot of the plant. So here are some normal plants over here, where they waited for 18 months before they went back in and replanted alfalfa. And here are some plants that were where the stand was taken out and then replanted just 2 weeks later. The taproot is gone. The plants have tried to compensate by making new branched roots, but this is never going to be a plant that is able to produce as well as the normal plant. And this is where what it might look like in a field. If you were to just look at this field over here on the left, it might look okay. And this is a plant field. The previous crop was alfalfa. They had a year of corn in between and then replanted the alfalfa. The year that they had the corn was a drought year, so they probably did not get as much reduction in toxicity as they expected to get. This field over here on the right had always been in corn until alfalfa was planted in 2013. And you can see the difference visibly in how vigorous these seedlings are on one side of the field versus the other. So how much alfalfa do you have to have in a field to actually have a problem with your autotoxicity? This is based on classic work that was done at the University of Missouri by a colleague of mine, John Jennings, a few years ago. And basically, they did this really cool experiment where they took an established alfalfa plant and planted it here in the middle. So it had been there for a few years. And then they planted seedlings on spokes going out from that original plant at a certain spacing in all 4 directions. And looked at the survival and productivity of those seedlings. So what you see here within an 8-inch radius of that original plant, it's quite likely they actually had seedling death. And an 8-inch radius in a field works out to be 3.5 crowns per square foot out there. Within a 16-inch radius of that original plant, they were seeing auto conditioning. So they had plants, but they were not performing very well. And that works out to only 1.4 crowns per square foot. We generally tell people that the economic replacement threshold for alfalfa is 5 crowns per square foot. So even either of these situations, you have a population of alfalfa that is well below where you would start to think about replacing the stand. And what that means is in any economic stand, you probably do have autotoxicity at the point where you would want to replace. So this means you have that waiting period, which has been proposed to be anywhere from 2 weeks to 2 years. I've even heard 3 years floated. And this is also the practical reason why you can't thicken an alfalfa stand during its lifetime. So what can we do about it? Typically, we're going to have, most of the time, we're going to say 6 to 12 months after termination will probably be sufficient in the climate that we are in, where we have rainfall. So you have 2 strategies there you can use. One is fall termination of your alfalfa, let it fallow over the winter and then replant in the spring and hope that your autotoxicity dissipated over the winter. Even better, however, is to terminate in the fall and then grow another crop before you replant the alfalfa. So you might have that corn year in between, or maybe an oats and peas spring crop, and then replant alfalfa as a late summer planting. Ordinarily, we would like to tell people not to till as much as possible. No-till is a great thing, but we do find that tillage will help dissipate alfalfa autotoxicity more quickly. That's probably a factor related to the exact surge in microbial activity you get during tillage is probably helping the microbes break down the toxin faster. But obviously it's also breaking down your organic matter and all the other things that we would prefer that you maintain. But this is one of the positive considerations for tillage. If you have a planting that failed, typically we tell people that if it is that first seeding year, you probably don't have much autotoxicity present and you could just go ahead and replant it. In personal experience looking at fields, I have seen enough evidence that you may have autotoxicity anytime that failed seeding has had time to flower, that I'm a little bit cautious about that recommendation. If you have a thinning alfalfa stand, you can't thicken it with alfalfa, but this problem doesn't affect any other forage planted into the alfalfa. So you can add things like red clover or interseed a grass, such as orchard grass, fescue, or timothy, into the alfalfa to get a little bit more lifespan out of it before you have to think about thinning or replacement, sorry. So one of the things that we're working on here in Michigan that you might have heard about is we've had the question, what if we actually had a lab bioassay that could tell us whether it is safe to replant the alfalfa? We do have things like this for herbicide residuals, where you can send a sample to the lab and they will grow some usually bean seedlings in it and be able to tell you whether you're safe to plant broadleaves. It seems sensible to me that you could have something similar to that would work for alfalfa. And then we don't need to spend as much time thinking, well, what do we have to do to dissipate the toxin? We could just do the bioassay and give the farmer an answer to say, yes, you have some toxin present, don't replant yet, or no, you don't have any toxins and you could go ahead and plant. So we are working on a bioassay to do that in the lab. And we're using something called the soil on agar method, where we have, as shown in this top picture, we have some little square flasks. We have a clear agar in the bottom, and then some alfalfa soil from different fields layered on the top, in which we plant some alfalfa seedlings. Then we're able to see the structure of the roots as they come through into the agar, and we've seen some pretty interesting structures on the roots that are not normal, such as these really curly ones. And then we can, after only 4 days, we are able to differentiate seedlings that are grown in the different soils. Some of the things that we're finding is that the alfalfa seed variety does seem to matter. Both the variety that had been in the soil that was creating the toxin, but also the variety that we're using here in the bioassay. And what that's telling us is that there are genetic differences among alfalfa varieties, either in or both in the amount of toxin that they are producing, but also in their ability to tolerate the toxin. And so that may actually be a big piece of the variability we see from field to field in real life. And again, this is something, once we have this assay worked out, we could start to screen varieties during the breeding process and select them for positive aspects of this trait. So we're still working on fine-tuning this. COVID really threw a big monkey wrench into progress, but we're starting to get back on track here. And we're hoping ultimately that we would actually have an assay that could be performed in soil labs to help the farmer. And that is what I have prepared for today. I see we do have a few questions in the Q&A. I'm going to stop my share so we can get into that.
Yeah, thank you so much for your talk, Kim. Wow, we covered a lot of ground, and there's some great questions that have come in just to dive a little bit deeper into some of those topics. So The first question relates to the research that you were doing with some fungicide. And they're just wondering, what growth stage was the fungicide applied to the alfalfa?
Okay, typically we put the fungicide out there when the alfalfa is about 8 inches tall. So for the first cut, we just look at height. So as soon as we have 4 to 8 inches of height, we're out there putting it out. For the regrowth cuttings, because there is a withdrawal period before you can cut, we want to get it out usually about no later than 3 weeks after we cut it. So
Okay.
yeah, you have to have, you have to look at the label for the particular herbicide that you have to. We were using Priaxor. There are other options, and they might have slightly different label recommendations.
Yeah. So always read and follow the label.
Always read the label. Yeah. Don't just, that lady in the webinar told me to do this.
It is a legal document. It's a fantastic question to get some context for what Kim was seeing in her trial, but yeah, read the label, please. So we've got a few questions come in about the grass alfalfa mix trial. So first of all, what proportion of those binary mixtures were alfalfa versus grass?
Okay, they were all planted as 50-50. All right. When we put them in the ground. Now, you don't find, I have some more information on that sort of, I decided not to emphasize that here today for time reasons, but you will be seeing more information come out of that study because obviously we see a lot of variability from cutting to cutting. So the first cutting is going to be mostly grass. And then the subsequent cuttings are going to be much higher percentage of alfalfa. And on some of those, by the time we get to the late season cuttings, we barely have any grass left in them. And there's certainly something to be said for looking at grass mixtures. How much does the proportion that you plant affect that? We chose 50-50 for that one, but I am working on a proposal right now to try and get some money to look at a little bit more information about seeding rates and how we can fine tune that.
Very cool.
Because some of those, sometimes you can end up with very unexpected results from what you put out for your seeding rate. I'm sure you've seen that in your work.
Definitely.
It's like, it's very difficult to accurately target. I want this percentage of grass and this percentage of alfalfa, and I want it to always be the same. It's not going to happen.
So another question about those mixtures, is there also some sort of synergy with the grass alfalfa mixtures? Because we saw that all of the binary mixtures out yielded the single species plots. Can you comment on that?
There undoubtedly is, because you can visibly see on these plots, I could have put a picture in, but I didn't. We're applying nitrogen fertilizer to the grass only plots on, typical schedule, but there's a visible difference in how much better the grass looks where it's in the alfalfa. And so that's probably related. It's just darker green and more healthy looking. It's probably just getting a better nitrogen supply. Because of course that alfalfa is fixing nitrogen. It's not giving that nitrogen directly to the grass, but as the leaves and the roots break down in the soil, it does change the nitrogen availability in the organic matter in the soil that the grasses can then grab it. And that probably has a big part of that. Again, I'm trying to expand what we're looking at to try and get a better handle on that. Because it's a very interesting question. And I've seen that in many, many studies of many types over my career that a stand that's fertilized with fertilizer does not behave the same way as a stand that is got a legume growing with it. And I think it's a much more complex question than just how much nitrogen was available. There's probably some other things going on there.
For sure. Would you be able to share your thoughts on why the meadow fescue did so much better than the other grasses in that trial?
Yeah, that was actually a big surprise to me, because we've done a lot of work with our variety tests here with meadow fescue, and we don't typically see it perform that well. I don't know if we just happened to get a really good combination of weather conditions that were helping it, or did we pick a really bad tall fescue variety. We had a really good orchard grass variety. We were pretty happy with that one. Was it was Echelon, which is one we've had really good luck with here. But the meadow fescue kicked its butt. So that was unexpected. I'm not sure I would go out and tell everyone to just buy meadow fescue, because it doesn't always do that well. But again, if we could figure out the synergy between it and the alfalfa, we might learn more about that.
Yeah, that would be some cool information to have. So switching gears a little bit, we've got some questions about the grass maturity index that you guys are working on. So one question is that index considering growing degree day accumulation when determining heading dates?
That is one of the things that we are going to incorporate. We're collecting the data so we can put that in. Part of our question with that is how well growing degree days is actually going to work across the country, because growing degree days might work pretty well for alfalfa, but one of the things that we see with grass species is that they also have a very strong response to solar radiation, which probably tracks sort of closely to growing degree days, but not necessarily exactly the same, because growing degree days is just about temperature, whereas solar radiation incorporates cloudiness.
Would it also incorporate day length?
And day
in case
length,
there's any
yes.
day length
Cloudiness,
triggers
yeah,
for heading as
yes,
well? Okay,
absolutely.
cool.
So,
Very cool.
but we are trying to put all those pieces into it and see how we might be. That's one of the reasons this hasn't been done before, is because it's not as simple as just doing something like a maturity index for corn or soybeans, or because there's a lot of different factors.
They just need heat. Well, soybeans,
Yeah,
I think, have some day length stuff going on, but corn just needs heat.
Right. Yeah. Corn just needs heat. So it's easy. But there's more than heat involved with the grasses. But we were very encouraged by the preliminary analysis we did. I didn't show the statistics on that chart, but the statistics indicated that the ranking of grasses was consistent across locations. So that is what's giving us some, or the ranking of heading dates was consistent for some varieties, not all, but that's where picking the right varieties to be those reference varieties is going to be important.
Okay.
There were some surprises.
I bet.
You know, I want to know what varieties they are, but they're not, one person knows. Ray Smith at University of Kentucky knows which variety is which, and he's the only one until we do the big reveal.
Gonna have to find out what kind of coffee he drinks.
I know. He doesn't actually have any plots. He's just the keeper of the
so he's just the keeper of the codes.
Yeah, and he has all the seeds. So when we start any new site, he packages it up and sends it out to everybody with the codes. And
okay. All right.
So this is a blind study, which makes it kind of interesting too.
Yeah, those are going to be very fascinating results when that project wraps up. Before we run out of time, I do want to switch gears again, because you covered 3 very distinct topics here, and we've got some autotoxicity questions. So you kind of touched on this a little bit, but just to reiterate, is autotoxicity present in a seedling stand, like a new seeded field, kind of within that first 6 months?
The conventional wisdom is that it is not. Actually, that it will not be present for the whole first year. And if you read almost anything, that's what it's going to tell you. But I have seen, in my experience, a number of cases where we told farmers that, and they went out and tried to reseed the field and had another fail. Now, a caveat with that is if they didn't fix whatever it was that caused the stand to fail the first time, before they try to reseed it, it's entirely likely they might have a second fail.
Is it autotoxicity or is it something else? Right.
Yes, exactly. Yeah. And oftentimes people don't pay as much attention to things like pH and other nutrient things. It could be weather related. It could have nothing to do with what the farmer did. But if you're still in a drought situation, it probably is not going to be any better the second time. But I've seen that often enough that I've become kind of leery about just giving people a blanket recommendation of, oh yeah, it's okay to take it out and start again. You want to take a close look at it. If we can get this soil bioassay up and going where people can send samples in, then that would give them information. They wouldn't have to guess about that either.
For sure.
So,
do you know if yellow flowered varieties of alfalfa are subject to that same autotoxicity?
That is actually another excellent question that I hope to look at, because I've had that same question come up in my head. Those grow a little bit differently. Do they have the same problem? I don't know that anyone knows the answer to that. We assume that they do, but we've seen enough genetic difference here. There can be very obvious genetic differences between varieties. They're not all the same. That makes sense. And when you stop and think about it, but it's not something we've ever selected alfalfa variety for. And I actually have a new breeder, Ginny Moore at Cornell, is going to be doing some alfalfa breeding, and she's already contacted me that she's very interested in incorporating some screening for this into her breeding program.
Cool.
Once we get things moving along. So now that COVID, I hope, is not affecting our research programs as much, and we can just start making forward progress again. Hopefully things will pick back up.
Yeah. Our next question goes back to those third-party variety trials. You mentioned that quality should be something that we're looking at, and in general is not. Are there any plans to start doing more quality analysis on those kinds of trials and reporting those results?
Probably not. I mean, I've floated the idea a few times with companies, and typically they just go, no, we don't want to do quality because it's affected too much by management. Now, I can see that argument when you look at grass trials. Yes, because you have such a huge influence of maturity. You can have a 2-week difference between one variety and another, and picking one date to harvest them all at is obviously going to really stack things. But with alfalfa, I think that the maturity differences are mostly related to fall dormancy. And so it would be much easier to adjust for that. It's mostly a factor of that they don't want to pay for it, because it's going to increase the cost of the test. Mm-hmm. And most universities, the reason that we're seeing fewer and fewer tests is because universities are demanding that the tests be able to pay for themselves. And that makes the cost go up because the university's not subsidizing it anymore. And that makes the entries go down because now it's too expensive and the seed companies don't want to enter. And then and then you have to charge more because you have fewer entries, and it's an economy of scale, and it just becomes a vicious cycle.
And it's one that we already hit the end of several years ago. Yeah. For those that aren't familiar, we used to have third-party variety testing in Ontario. We don't anymore because CFIA removed the requirement for third-party testing to register varieties in Canada. So they'll accept the company's trials for the registration purposes, and then it became that cost cycle that Kim just described, and that's why we don't have them anymore, unfortunately.
Yeah. So adding anything that increases the cost of the test, I'm somewhat skeptical is going to fly. But there are discussions going on, at least here in the States, regarding the future of forage variety testing. Some of the companies are getting involved in this because they're actually starting to see entries are so low in many cases that they can't even get a good estimate of how their variety compares against others. And they need to know that because they can't make progress in breeding if they don't know where their variety falls on the spectrum. So, it's possible that as a result of that, there may be some adjustments in how variety testing is done that might preserve it. But You know, it's an extremely valuable tool for the farmer, but it's only valuable if you have a lot of entries in there. You know, if it's only a very small subsection of the available entries and the other ones are never compared, it isn't really very useful for anybody. So it is a significant problem right now to get that third-party data.
For
And
sure.
it's not just forages. You know, my colleague in corn is having the same problem.
Yeah. All right. We're gonna field a couple more questions to bring the mood back up, because variety testing can take a very sad turn.
It does take kind of a sad turn.
So back to the grass alfalfa mixtures. Just to clarify, you said that those trials were planted as a 50-50 ratio. Was that on a weight basis?
That is on percentage of the recommended seeding rate. So for example, if our recommended seeding rate was 16 pounds for alfalfa, then we would cut that in half and plant 8, and then we would use half of the recommended rate for the grass.
Okay. All right.
If you do it purely on a weight, if you do it on purely a weight basis, say for example something like Timothy, which has a tiny seed, if you did it just purely on a weight basis, you'd have crazy too much Timothy.
For sure.
Yeah.
With the autotoxicity, are there crops in that in between alfalfa period that are better at dissipating that toxic effect than others, maybe due to root structures, or we probably don't know why, because we don't totally know.
Yeah, I don't know that any, no one's really done any work on that either, but it's entirely possible that that is true. See, part of the problem with the autotoxicity is because we don't know exactly what's causing the problem. It's really difficult to monitor what is happening and then be able to relate it to, it was due to autotoxicity, or was it something else?
Right.
That's another piece of this picture that I'm hoping we can get at through this work, is once we have a better way to actually evaluate soils that have the toxin in them, we may have a better shot at being able to identify what the toxins are. And then we can start to address questions like, did corn give you a better dissipation than sorghum, or, whatever. I think, my working hypothesis at this point is anything that boosts your soil biology is going to speed it up. Because
it'll be interesting to see the results, to test that for sure.
Yeah, it's going to be fun.
So we've got time for one last question. When we're cutting alfalfa, what's the optimum cutting height? How much stubble should we be leaving behind?
Alfalfa's pretty tolerant of being cut low during the growing season. You can take it down to 1 inch. The thing with alfalfa is you're trying to encourage it to grow back from buds that are below ground. So the more stubble you leave above ground, then you have the possibility that it might actually grow back from stem buds instead of crown buds, and that's not what you want it to do, because the stem buds aren't going to have as big a shoot on them. But you also have to weigh that against how much dirt are you going to suck up into your crop from trying to shave the ground, which actually the ash content can become a bigger question there than simply what is it doing to your alfalfa plant.
And because in Ontario we love our alfalfa grass mixtures.
Yes, if there is a grass in there, you have to cut it high. Yeah. For a grass, typically we would recommend 4 inches if you can set it that high. That's hard to do with some mowers, but that's the ideal, because it doesn't matter to the alfalfa if you shave the ground, but it sure does matter to the grass. And the second piece of that is, if it is your last cutting of the year, even with a pure alfalfa, I would recommend to leave a taller stubble, because that's going to help with your winter survival. If you can leave some stubble out there that will help catch snow to provide that insulating blanket over the ground. So I usually tell people, try and leave 4 to 6 inches of stubble with your last cutting if possible.
All right. Well, we are just gone 1 o'clock. So thank you so much, Kim, for your presentation and for answering some questions. I'm going to turn things back over to our Forage Council President, Terry, and let him give us some closing remarks.
Great. Thank you, Dr. Cassida. That was an excellent talk, and we appreciate you taking the time to be with us today. Thanks again to our sponsors for their support of these webinars. It is with everyone's great support that we can put on this program and be a successful program for everyone to view at a later date on our YouTube channel as well, and appreciate all the sponsors that help make this work. I'd also like to give a special thank you to Christine O'Reilly and Patricia Ellingwood for putting this together and all their behind the scenes efforts that put the Forage Focus together. And we really appreciate that as well. So thanks again, everyone, for the 2021 Forage Focus, and hope to see everyone again for future events by the Ontario Forage Council. Thanks and have a great day.